Hi everyone, welcome back to Tech-Bimba channel. In the last video, I talked about tokenization. In the today's video, we will deep dive into transformer architecture. So this is how the transformer architecture looks like. On the left side, we have an encoder transformer. On the right side, we have the decoder transformer. At the high level, encoder transformer reads the user input, understands the relationship between the words, and creates a contextual representation of the sentence. The decoder uses the understanding to generate the output text token by token. Today we will first focus on the encoder transformer, then we will move on to the decoder transformer. So these are the steps involved in the encoder transformer flow. We will go through these steps one by one. Let's say user provided the input sentence, the cat drank milk. This sentence is broken down into words. As you can see here, there is one word, cat is one word, drank is one word, milk is one word. And for these words, number will be assigned. This process of converting text into numbers is what we call it as a tokenization. Tokenization is a very important step here because these models understand the numbers better than the text, and also a lot of math is involved here. Because of that, this tokenization is a very prerequisite important step here. Once the tokenization is done, tokens are sent to input embedding. In this step, tokens are converted into dense vector. We can think of a input embedding as a coordinates in the huge mathematical space. Here, words with the same meaning stay close with each other. In this example, we can see that cat and dog are the animals, they are staying close with each other. Table and chair are the furniture, they are staying close with each other. Car and bus are the vehicles, they are staying close with each other. Input embedding helps the model to understand the relationship between the words and its meaning. When I say meaning, let's say first we got the sentence cat sat on the table. Model first figures out that cat is an animal and table is a furniture. It figures out in this case it has to move in this downward direction. Next time when we get a sentence dog sat on the chair, so since a model is already aware in case of an animal and a furniture, that relationship is always downward. So it will figures out that it has to go in that downward direction. This is how input embedding helps to determine the meaning of the word and the relationship between the category of the words. Let's see how this embedding looks visually. Let me go to this link. This is the TensorFlow embedding projector. Here every dot represents a word. We can zoom in, we can rotate, we can explore how words are positioned with respect to each other. We can also explore the relationship here. Usually words with the same meaning are kept close to each other. What we are seeing is the embedding in a 2D or a 3D space. Usually in a real world transformer, embedding exists in a very high dimensional, like in 100 or 1000 dimensional. In case of a input embedding, words will be processed parallelly. Once the input embedding is done, model can understand the meaning of the words and also the relationship between the words. But there is a one problem here. Let's take a two sentences. Dog bites a man, man bites a dog. Both the sentences contain the same words, but the meaning of the sentence is completely different because the order of the words is different. With only input embedding, model can understand the meaning of the individual words, but it cannot fully understand the sequence or the order of the words. This is where positional encoding comes into picture. Positional encoding adds the positional information to every token. For example, in case of a first sentence, it adds the information like dog is at the position 1, bites is at the position 2, man is at the position 3. In case of a second sentence, it adds the information like man is at the position 1, bites is at the position 2, dog is at the position 3. So combining input embedding plus positional embedding, the final embedding is the one going to form. This final embedding knows the meaning of the word and also the relationship between the words and also knows the sequence of the words. So with this model is now completely aware of the meaning of the words, relationship between the words and also the sequence of the words. Once the final embedding is done, it is sent to multi-head attention. Before diving into multi-head attention, let's try to understand the attention. Let's say we have a sentence, the cat sat on the mat because it was tired. As a human beings, we know that it is referring to cat only, but the older models like RNN, they struggle to understand its meaning. To resolve that in a transformer, there is a concept called as attention. In attention, words or the tokens in the sentence, they talk with each other to understand the context. In this diagram, we can see here every word in the sentence are talking with each other. It is directly talking with a cat. Because of that, model understand it referring to the cat only. So it will clearly understand the relationship between the cat and it. So in the attention, words or the tokens in the sentence, they talk with each other to understand the context in the better way. Now let's talk about the multi-head attention. Let's say we are watching a cricket match. When we watch the cricket match, we will observe who is batting, who is bowling, what is the current run rate, what is the economy of the bowler, how the field is being set, and so on. So we observe the game in a different perspective to understand the game in a better way. Similarly, in the multi-head attention, there will be different heads. Each head will be focusing on the different perspective. One might be focusing on the grammar, one might be focusing on the meaning, one might be understanding the relationship between the subject and object. So in a multi-head attention, the tokens in the sentences, they talk with each other in a different perspective to understand the context. So at the end of the multi-head attention phase, model will be aware of the entire context of the sentence. After the multi-head attention, information will be sent to feed-forward network. This is the processing step where it processes the information collected by the attention step. It learns about the complex patterns present within that information. In simple words, attention is the collection step where it collects the information at the different perspective. Feed-forward network is the step where that information will be processed. So in this step, it learns about the complex patterns present within that information. At the end of this phase, model understands the each and every pattern, and it also learns about the each token in a much better way. Once the feed forward is done, the same block of a transformer will run again and again. This is what we call it as a repeat multiple layers. Within each layer, the understanding of the sentence will become more clear to the transformer. Let's say we are reading this sentence. Once we read the sentence for the first time, we might not get the entire sentence. So we read the same sentence again and again. Once we read the same sentence again and again, the understanding and the context of the sentence will become more clear to us. The same thing will happen here as well. So in case of a encoder transformer, the same sentence will go through multiple iteration or the multiple layers. So within each layer, the understanding of the sentence, the understanding of the words, relationship between the words will become more clear to the transformer. Once all the steps are done, to encoder transformer flow now completely understand the context of the sentence, and it will generate the contextual representation, what we call it as a context of the sentence. After the encoder transformer, the decoder transformer starts. It will predict one output token at a time. Let's understand this with an example. Let's say user has given an input sentence, tell me about cricket. Encoder transformer understands each word, understand the relationship between the words, and creates the context or the representation of the sentence. Now decoder transformer comes into picture. It will start with a special token called as a start. This will be passed to the output embedding. This output embedding is similar to the input embedding we discussed in case of a encoder transformer. Here the token is converted into the dense vector. In this phase, meaning of the words will be resolved, and how one category of the words are related to the other category will be understood by the decoder. After that, positional encoding comes into picture. So this positional encoding is also similar to whatever we have discussed in case of an encoder transformer. So this assigns the positional information to the token, like this is the first token, this is the second token, so on. So together, output embedding plus positional encoding forms the final embedding. This will be passed to the master multi-head attention. In a master multi-head attention, decoder understands the relationship between the each token. It is being called as a mask because it only understands the relationship between the already created tokens. It won't consider the future tokens. After this attention, there is a one more attention called as the cross attention, or we can also call it as the encoder decoder attention. In this phase, decoder reads the context created by the encoder. Then this will be sent to the feed forward network. In this phase, it will further process the understanding, and it increases the probability to predict the output tokens. After that, same decoder will run multiple times. With each layer of execution, it refines the understanding deeply. After all the layers are executed successfully, it generates the output vectors like cricket, football, movie, player. So these are the probable words out of which any one can be an output token is what it means. This will be sent to linear layer. Here the scores will be assigned to the output vector. As you can see here, for the cricket, score is 0.70. For the football, the score is 0.20. For a movie, it is 0.005, so on. These scores will be sent to the soft max probabilities. Here, the scores are converted into the probabilities. Like cricket might be getting the probability 70%, football might be getting a 20%, so on. Now, the output vector that is having the hash probability will be chosen as the output token. In our case, cricket is the one that is having the hash probability. So at the end of the first iteration, cricket becomes our first output token. Now this will be appended to the input to the decoder. So in the second iteration, so cricket will be appended to the input. So in the second iteration, we can see that start and cricket will become the input to the decoder. This input will go through all these steps. Let's say at the end of the second iteration, it predicted the ease. Now in the third iteration, this ease will also appended to the input. Okay, in the third iteration, we can see that input becomes start cricket ease. Let's say it predicted the output token as a in the third iteration. So in the fourth iteration, input will become start cricket is a. So this loop continues until decoder predicts the special token called as a end. Once it predicted the output token end, that is the stage where decoder stops predicting the output token. That is the stage where user will receive the output tokens. This is how the decoder works. Hope this is clear to you guys, how decoder and encoder works and how transformer altogether basically uses this decoder and encoder to generate the text or the tokens. If you found this video is helpful, please like, share and subscribe to the channel. Thanks for watching.